Okay, so now just to recap what you have learned last Thursday and Friday. Now we went over a bunch of identities, and what you just did. I wish you can. I hope you can fluently tell others what these identities are, and be able to find out what they're equal to swiftly. So not just that you know these identities, but you know how to rearrange them so that you know what they're equal to, because you are going to see the variety of these identities. And today's stuff is actually easier than what you did last Thursday and Friday. It's easier because what you need to do is to show how the left-hand side is equal to the right. That means you are given an answer. Last Thursday and Friday, we just say, hey guys, go ahead and simplify. We didn't tell you what the answer is. We just said, all right, just move, just go as far as you can. So that's kind of risky if you don't know what you're doing. But now at least we say, all right, guys, can you see how the left is equal to the right? If you do, please show it. So we say, well, can you see how the left-hand side is equal to the right? Now, I'm going to just we'll go through a few questions, and then I'll leave the rest of the period for you to do it yourself, because I need you to try it. And I need you to be to train up your sensitivity. Like, for example, can you see something special when you look at the numerator? That's equal to 1, all right? So that should come into your head right away. But oh, yeah, the numerator, it's equal to 1. And again, as I said, you've got to see the mental math. You've got to train up your mental math capacity, especially you're going to calculus next year. You have to expand your mental capacity. You have to see how the next step and the step after that will be carried out, because the second step will be your justification of your first step. And when we say cosine square theta times secant square theta, should we think about secant square theta as 1 plus tangent theta, 1 plus tangent square theta, or 1 over? We'll say we prefer to think about this as 1 over cosine square theta because they cancel each other out. So you get 1 over 1, and that's equal to 1, and we're good. You cancel what? You cancel out this cosine and this cosine, this cosine? You cannot. You know why though? Because we're adding. You cannot do that. You're adding. Now this is also the value for this topic, because this topic is going to run through a bunch of simple algebraic skills, like doing common denominators, simplifying. And this is the unit. You want to consolidate and ask all those questions. And I don't want you to just knowing what can be done and what cannot be done. I need you to know why it can be done and why it cannot be done. As I said, if you don't understand the why, things are not going to stick in your mind. Just like everything in life. If you don't understand the why, nothing's going to stick. Okay? Now, if you remember the tips that I gave you from last week, my tip number 1 was put things into sine and cosine. And my tip number 2 is to have common denominator. Now, you have 2 fractions. You have to show how the left is equal to the right. And I would say, well, if I have 2 fractions, I'm going to contemplate the possibility of having common denominator. But now, can you see what the common denominator it's going to be? Now, I'm going to say, can you see the common denominator being ultimately sine square x? Can you see it? Because when you do the common denominator, and I'm just talking about denominator at the moment, you will have these two multiplying together to have a common denominator, which is A minus B times A plus B, which gives you A squared minus B squared. And what is 1 minus cosine square x? That's sine square x. Now that's the kind of mental math I want you to get ready for. I want you to think about this mentally, that this is what you have for the denominator. I need you to see how that is going to play out to be. And I hope now you can see why I gave you the matching activity. Because if you cannot see how this, it's equal to sine square x, that's no moving forward. You just stare at these expressions, you're like, what am I doing? What am I supposed to go? And that's why I also said you've got to see 2 steps ahead. If you cannot see how you're going to get this, you will have no justification whatsoever to put those 2 fractions together. But now, what about the numerator? Well, when you do your numerator, your elementary school skills, right? You want to have a common denominator. So for the first fraction, you've got to multiply 1 plus cosine x over 1 plus cosine x. For the second fraction, to have a common denominator, you've got to multiply 1 minus cosine x over 1 minus cosine x. So there you can see something. You can see how the cosine x got canceled out. So you're down to a number 2 in the numerator. So now can you see it is equal to 2 times cosecant square x? Okay. So this is why I say it's easier, because you have the answer given to you right here on the right-hand side. All you're doing is to change the left-hand side to become the same thing as the right-hand side. And you may not think it's possible, but it is always possible. When I was doing this, when I was young, I was like, is it like a typo? Is it possible, really? And I always questioned, and it turns out that, well, the teachers, they check the math, and it's always possible. So what you need to make possible is, can you handle the mental math in your head? Okay, see 2 steps. Okay. Now let's go to the back. I'm going to pick a few questions. Okay. Now I'm going to ask you to look at this. Okay, you can put down a pencil first. All right. Can you see how the left-hand side is equal to 1? Can you see it? Can everyone see it? Okay, because sine x times, we change this to 1 over sine x, right? You can cancel it out. So that's a simple 1-step mental math. Now, what about number 2? Can you see what's going to happen to the left-hand side? It becomes what? It becomes 1 minus sine square x, which equals to cosine square x. Okay. Now, I would like to just take a moment to talk about number 3. So now, I also want you to learn how to think more purposefully. Look at number 3. Ooh, this looks familiar or not. It looks like something, right? Well, if it's cosine squared plus sine squared theta, then it's equal to 1, but it's a minus. So no, you cannot touch the right-hand side. That's the whole point. You're verifying, you're touching, you're only working on one side and one side only. You have to show how the left is equal to the right. So now, how can you think purposefully? Well, on the right-hand side, you can see the sine square, right? Now on the left, you see cosine square x, but you don't see it on the right-hand side. That means if you're going to change, you're going to work on the cosine square x. So now you think about, what does cosine square x equal to? You say, well, I'm thinking about 1 minus sine square x. Would that work? And you say, well, you have 1 minus sine square x minus sine square x, and that gives you 1 minus 2 sine square x. So if you see cosine on the left but not on the right, that means it has to be gone. It has to be replaced by something. And what is that something? Well, then you think about what you know about cosine square x. Draw it out. Okay. Again, this is called verifying. You're verifying the left-hand side being equal to the right-hand side. You're not supposed to mingle things left and right together. That's why for the previous questions, we have been just working on the left. Yeah, we're just proving basically. All right, now we look at this one. So we'll say, well, how can you show the left it's equal to the right? How can you show the left it's equal to the right? Now we can see here, it's that the left-hand side has all things in sine, the right-hand side is all things cosine. So take a moment and think about it. What can you do? Okay, again, like I said last Thursday, you always think about what can you do before you think about what you should do. What can you do over here? I'm going to give you a hint. Can you see how the left-hand side will become, at least temporarily, can you see how the left-hand side could get to this? Can you see the how? Can you see how the left-hand side, only left-hand side, can you see how the left-hand side becomes this? What needs to happen to give you this? It's about the Pythagorean theorem, yes. I mean the Pythagorean identity, yes. But how can we make this happen? So we're gonna factor out the sine square x first. You factor out the sine square x on both terms. This is sine square, this is sine to the 4th power. You factor out the sine square x. That's how it becomes 1 minus sine square x. And 1 minus sine square x, we know that it's equal to cosine square x. Now, how do we get rid of this sine square x? Well, we will replace it with one minus cosine square x. And then you distribute this back into the parentheses. Well, that's how you can get cosine square x minus cosine 4th power x. Okay. All right, so I'm going to let you try it out with your partners. I'm going to work out the keys right here. So you can, I would strongly suggest you to try and bump around Okay, you're trying, it's very crucial. You want to register all the looks that you're seeing and put them into your own repository here in your head so that when you see them again tomorrow, you'll be ready for it. Okay, so let's see if you can connect the dots. Okay, so I gave you some dots right there, some hints to see if you can make the connections. I know it could be difficult at the very beginning, but I want you to slowly enjoy the process. And I did use the word enjoy. Okay, if you cannot find this as an enjoyment, I would like you to try to feel that way. Now, for number five, so how can you go from the left-hand side cosecant square x over to cotangent x and then turn all the way down to 1 over sine x and cosine x? What needs to happen? What needs to happen? Okay, so now, so that's correct. Okay, so when we have situations like this, it's very important that you know how to handle things called complex fractions. Well, what do we know about cosecant square x? Now, like what we said earlier, you got options. You can think about this as 1 over sine square x. You can also think about this as 1 plus cotangent square x. Which one is more applicable here? The first one or the second one? We'll say, well, it seems like the first one is more applicable here because we don't see any addition on the right-hand side. So if we have to make a decision of which one to think, that's a thought process. You are thinking about the possibilities of rewriting cosecant square x. Well, what would that be? Well, you think and see which one is more likely. Now I'm going to write this down as a complex fraction first. 1 over sine square x. And then cotangent becomes cosine x over sine x. Now, how many of you feel uncomfortable dealing with complex fractions? Raise your hand if you are uncomfortable. Just be honest. Okay. Now, I was, just like you, feeling extremely comfortable. I remember that my teacher said something about flipping, which one multiplies by what, and it never stuck in my mind. Then what? I need to get it right. So I actually went back all the way to elementary school math and think about this. Well, what is the meaning of a complex fraction? The meaning of a complex fraction is simply this fraction, the top fraction divided by the bottom fraction, meaning that you are more than welcome to write this as the top fraction divided by the bottom fraction. And back in elementary school, what do you do when you divide by a fraction? We multiply by the reciprocal, right? So we are not learning any tricks. We are not learning anything new. We're just, having a little renaissance here, just going back to old days. And say, well, now you can see the fraction not as a complex fraction. And now can you see how it is 1 over sine x cosine x? Because of the cancellation here. And if you have this, then you will have cosecant x times secant x. So a lot of times you will come across with the situation of a complex fraction. And don't get scared by the complex fraction. Just use the old school method. You are just dividing by a fraction. Just go ahead, make it to a multiply. You multiply by the reciprocal. You are not learning anything new. Just using the good old days knowledge from your elementary school math teacher. Questions about this one? Okay. All right now. So what about here? Now, for cotangent x, I'm going to ask you a question for cotangent x right here, cotangent square x, sorry. Is it better to think about 1 over tangent square x, or is it better to think about this as cosecant square x minus 1? Top or the bottom? The bottom one. And what's the hint? What's the signal that gives you that the bottom one is a better choice? This is subtraction, right? This is subtraction. So we're like, oh yeah, so we're gonna do the subtraction one because we have this. And if you have a subtraction and then you have a common denominator, that's how you can split them. And that's how you can get cosecant x minus sine x. Okay, so again, you've got to know your identities. You've got to know your possibilities. You've got to know how to make a decision. How did you get what? Here? You have a common denominator and you have a subtraction in the numerator. That means you can split the fractions. That's why we call it common denominator, because they are from both fractions. Okay, and this is one of those skills that you should have in your head before you go to calculus, is that whenever you have a common denominator, you are more than welcome. You're free to split it back to 2 fractions. But you cannot split a common numerator. There's no such thing as common numerator. You have a thing called common denominator. All right, number 7. Okay, so for number 7, I raised the question of, can you see, well, I'm going to give you a hint. Can you see cosine square x over sine x? Well, how could that happen? Well, if you have secant x in the denominator, that means you can move it to the, well, how about this? Let me just use complex fraction then. Wait, no, 1 over sine x, and then sine x over cosine x. Yeah. Yes. Wait, hold on. Oh, no, cosine x, sorry. Also, something doesn't seem right. All right, so 1 over cosine x times sine x over cosine x. Well, that's equal to 1 divided by sine x cosecant x. I mean cosine square x. So 1 divided by sine x over cosine square x. And again, you will change division to multiplication, and then you do the reciprocal. That's how you get this. And what's going to happen if you have this? Well, cosine square x is equal to 1 minus sine square x. And again, you have a single common denominators, and you are more than welcome to split. Yes. Where? Well, complex fraction, right? 1 divided by, well, what is this multiplied together? 1 times sine x is sine x. Cosine x times cosine x is cosine square x. So that's how you get cosecant x minus sine x. Again, as I said, I'm going to remind you one more time that you've got to think of the possibilities first before you write anything down. We are inherently stubborn as a species. We do not like to think we are wrong. So if you write something down before you see how things would turn out to be, it is going to be very difficult for you to change. All right, number 8. Okay, for number 8, well, my hint is this: can you get 1 minus sine square x over sine x? Well, the way you can achieve that is to change cosecant x to 1 over sine x. And then when you do the common denominator, you've got this. And once you have a common denominator, you can change the numerator into cosine square x over sine x. And that gives you cosine x over sine x times cosine x. And that becomes cotangent. Okay. Again, 1 minus sine square x, it's equal to cosine square x. And you can think about cosine square x as cosine x times cosine x. So therefore, you can make this a cotangent x. And cosine x just leave there by itself. Okay. Number 9, I think I wrote down it's easy. Don't overcomplicate it, because all you need to do is to make a common denominator of tangent x cotangent x, and by doing so, you have cotangent x plus tangent x. And what's tangent x times cotangent x? That's just equal to 1. They cancel each other out. So cotangent x plus tangent x is your final, which is equal to the right. Okay. So that's why I gave you the tip. If you see 2 fractions, explore the possibility of having a common denominator. Now, number 10, it's a bit complicated. So what I did was that I consider making the denominator something like a cosine square x by multiplying both numerator and the denominator by 1 plus sine x. Okay, 1 plus sine x. So the denominator becomes 1 minus sine square x, which gives me cosine square x. Okay. But now, how would it work out in the numerator? Well, you can clearly see some cancellation, but I'm going to change this here, so you can see better how things are being canceled out. So that's canceled, and that's canceled. So you have 1 over sine x times 1 plus sine x, and then minus 1. Now you can check the answer key for the complete work. Okay.